All right, so let's see this question now. So over here we are given an unsorted array, right? And what we need to do is we need to rotate the array to the left. That is in the counterclockwise direction by d steps, right? And d is also given in the input. And d is always a positive integer. That is something that is given in the question, right? Now what we need to do is we need to rotate this array in the counterclockwise direction by d steps, and we need to rotate it in place, right? We need to do this change in the array in place. That is, we don't have to return anything as an output of this particular function that we are going to write. We just need to do this reordering, this rotation by d steps in counterclockwise direction in place in the input array itself. We have to modify the input array, right? So that's the question. Now, if you check this particular example, the input array is 1, 2, 3, 4, 5. And if I rotate it by d steps, that is by 2 steps in the counterclockwise direction, it would become 3, 4, 5, 1, 2, because 1 and 2 would essentially go at the end of the array, right? Because I am rotating it in the counterclockwise direction, so I will just keep taking one element from the beginning and keep appending them one by one at the end, right? So initially, in the first step, when I'm rotating, I will take out 1 from the beginning and append it at the end. Now my array will become 2, 3, 4, 5, 1, right? And then in the next step, that is d equal to 2, I will take out 2 now and then append it at the back again, right? At the end again. So now my output will become, the array will become 3, 4, 5, 1, 2, right? Which is essentially my output because I have to just rotate it by 2 steps over here, right? So that's something that's what we need to do over here essentially. Now maybe you can just pause this video and try to think of a solution. And once you are done, you can just come back and check the solution here. Okay, now to solve this particular question, let's have an observation here, right? So where I'm saying that I'm actually rotating this entire array by d steps in the counterclockwise direction, essentially what I'm doing is I'm taking the first d elements from the beginning of the array and I'm just taking them out and I'm just appending them at the end as is, right? I'm just taking out 1, 2 and I'm just appending them at the end of this particular array so that now my 3, 4, 5, this segment of numbers actually come in the beginning, and this segment of numbers, that is the first d elements from the beginning of the array, actually go at the back, right, at the end, right? So if I actually visualize this way, that if I consider these two elements as one segment, right, and the rest of the elements, these three elements in this example, as another segment, essentially what I'm doing is while I'm rotating, I'm just reversing these two segments with each other, right? Essentially, I'm swapping these two segments with each other, right? If I swap these two segments with each other, 3, 4, 5 will come in the beginning and 1, 2 will go at the end. And that's essentially what I need to do, right? I'm just swapping these two, segments with each other, right? So now how can I do this, right? How can I do this swap? If I get a way to actually swap these two segments, or rather reverse the order of these two segments relative to each other, I will be able to like get my output, right? So if I have to reverse the relative order of these two segments, if I do a plain reversal, right? If I just do a plain reversal, an entire reversal of this entire array, what will I get, right? My resultant array would look something like this. It would become 5, 4, 3, 2, and 1, right? So it would become 5, 4, 3, 2, 1. And now if you see closely, then you would see that if I just mark the segments over here, my first segment, which is this particular segment, has actually come over here, right, at the end, right? And if you see this particular segment, 3, 4, 5, has actually come in the beginning, right? So even though we are saying, that the segments have got reversed relative to each other, the second segment has become the first segment over here and the first segment has gone towards the end. But if you see the internal order of the elements also for each of these segments, right? That is the order of the internal elements have also got reversed inside of each of these segments, right? So definitely the first part is fine, that my first segment, has gone towards the end and the second segment has come to the beginning. That is fine. That is something desirable. But what I'm also suffering from this plain entire reversal is that the internal order of the elements inside of each of the segment has also got reversed, right? Because of doing this entire reversal, which is not desirable, right? So if I can just prevent this second part from happening, right? This second part of the internal elements within the each segment getting reversed, if I can just prevent that from happening and just, you know, be able to reverse the overall segments relative to each other itself, then I would be good. I would be able to get my desired output, right? So now, again, right, I can do some kind of reverse engineering over here, right? Now I know for a fact that when I'm doing a plain reversal of the entire array, my segments are getting reversed, relative to each other. But since the internal order of the elements within the each segment is also getting reversed, what I can do is, before doing this plain reversal of the entire array, if I actually individually reverse the internal elements of each of these segments by myself first, right? So I make 1, 2 as 2, 1 and 3, 4, 5 as 5, 4, 3 first, right? Individually. And then I do an entire reversal, right? So then what will happen is that definitely, the first part will happen. That is my second segment will come over here at the beginning and the first segment will go at the end. That is the segments will get reversed relative to each other. That is something desirable. But again, as a side effect of that, now the internal order of the elements will get reversed. And since now they are getting reversed, they will come back to the original order because I have already reversed them once before doing the entire reversal, right? So I hope you're getting what I'm trying to say. What I will do is, see, I will just write it over here as a first step before even doing, the entire reversal. Yeah, so before even doing the entire reversal, what I will do is I will just reverse the internal elements of the first segment, that is the first D elements of my array. I will just reverse them to 2, 1, right? And also I will individually reverse all the internal elements of my second segment relative to each other, right? So now they will become 5, 4, and 3, right? So this is something I will do. I will do individual reversal of each of the segment, first D elements and then the remaining elements. And now if I do a plain reversal, like an entire reversal of the array, what will I get now, right? I will get 3, 4, 5, 1, and 2, right? And that is essentially my output, my desired output, right? And again, why we were able to get this? Because see, we know for a fact if I do a plain reversal, we have seen that the segments that we have to actually swap get reversed relative to each other, right? But since the internal order of the elements within each of the segment was also getting reversed, we actually reversed, the internal order of the elements beforehand, before doing the entire reversal. And now when the entire reversal operation is actually reversing the internal elements, they are actually nullifying the first reversal that I did for the individual elements of the individual segments, right? So I hope you understood what I'm trying to say. So essentially the algorithm is simple now. What we have to do is, in the input array, we just have to first reverse, the first D elements of the array, right? First two elements over here in this example. And then we have to reverse individually the rest of the elements, right? And then we have to do a full reversal of the array, whatever we got, right? So once I, just to repeat again, once I reverse the first D elements of this particular array, it would become 2, 1, right? And then when I reverse, the rest of the elements of this array, it would become 2, 1, and 5, 4, 3, right? Because I'm now just reversing these three elements. And then if I do a full reversal of this particular array now, I will get my final answer, my final output, which would be 3, 4, 5, 1, 2. And this would be my rotated array in a counterclockwise direction by D steps, right? All right, so now this is the entire solution. Now let's jump to our IDE and code this particular solution together. All right, so now let's implement the solution that we just discussed. So first of all, let me just declare a function. I will call it as rotate array, like this. And this will accept an integer array and also a positive integer D, right? Now what I have to do is, first of all, I will just capture the length of this particular array in n, right? Like this. And then what I will do is, I will just take d equal to d modulo n, right? And I will tell you why I'm doing this, right? Now, for example, let's say my input array is this, right? 1, 2, 3, 4, and 5, right? This is my input array. So now over here, if you see, my n would be equal to 5, right? Because there are totally 5 elements in this particular array, right? And now, for example, if my d is equal to, let's say, 5 itself, right? So my n is equal to 5, that is the length of the array is 5, and my d is also equal to 5. That is, I need to rotate this particular array in a counterclockwise direction by 5 steps, right? But now if I rotate it by 5 steps, I will actually end up having the same array, right? Because the length of the array is also 5. So I will have to rotate. I will keep taking out one element from the beginning and keep appending it at the end. And I will have to do it for 5 times. That is, I will be doing it for all the elements. So at the end of this entire rotation of 5 steps of this particular array, I will end up having the same array itself, right? So that is why this will be actually null and void, right? If I'm doing uh, n rotations where n is actually the length of the array itself, then I would be having the same array itself, and the rotations will be null and void, right? Similarly, if my n is again equal to 5 but my d is equal to 10 now, right? Now if my d is equal to 10, I will again like rotate it once, entirely, right? And I will get the same output, right, after doing 5 rotations. And then after getting the same array, after doing 5 rotations, again I will do 5 rotations, and again I will end up having the same array, right? So essentially what I'm trying to come to a point is that if you have d equal to a multiple of n, you will end up having the same array after doing all those d steps of rotations, right? So that's why if, for example, now you have d equal to 12, right? Then of course, as we know that first 10 rotations will be nullified, right? I will get the same array, but then the last 2 rotations, right, after 10, that will be something that will be effective, right? And that remaining 2 I can get by taking d modulo n. That is, 2 will be actually a remainder when I divide d by n, right? So that I can get by doing d modulo n, and whatever is my d modulo n, that will be my effective d, right? In case my d is actually greater than or equal to n, right? So that's why we are doing d equal to d modulo n over here, right? So I hope now it is crystal clear what I'm trying to say. I'll just, you know, get rid of this. I'll just keep the array as is because anyways we have to test this function after writing it. So I will keep this array as is. And now what I will do is, as we have seen, first we will, okay, now I have to reverse this particular array, right? So for that, let me do one thing. Let me actually declare another reverse function. Now we have already seen how to reverse a particular array. And if you don't know about it, and if you want to see like how to do it, I will just attach the link of that particular problem in this particular video. You will be able to see it at the top right corner somewhere. And you can just refer that particular video to know how to actually reverse a given array, right? But it's pretty simple. If you see this particular code, I'm going to write entirely here for you. So you will be able to understand. We are just going to have 2 pointers, left and right? And what I will do is, now I will run a while loop and I will say while my L is less than R, right? I will just swap the element at my left position with my element at my right position, right? Like this. Like this. And then after doing this swapping, I will just increment my left pointer by 1 and decrement my right pointer by 1, right? In this way, I will be able to actually reverse the entire array in place, right? So that's the entire reverse subroutine. Now what I can do is I can call this subroutine over here, reverse, and I can pass the original array. And now, first of all, I just need to reverse the first d elements of the array. So now my starting index, the left pointer that I have to send over here in this reverse function would be 0, and the r pointer would be actually d minus 1, right? Because first d elements would essentially mean starting from 0th index till the d minus 1 index, right? So that would be 0 to d minus 1. I have to reverse this, and this will be happening in place, right? So this function will actually be modifying the original input array itself. So I don't have to like take the output of this particular function in any other variable and use it, because anyways I'm not even outputting anything from this particular function, right? Just to be clear. So that's why I'm just reversing over here. This will just modify the input array itself. And then again, what I will do is I will again reverse, and now I will reverse from dth index till my end, right? N minus 1, right? That is, I'm reversing the rest of the elements now. And once I have actually reversed, the individual internal elements of both these segments, the first D elements and then the remaining elements, then I will just reverse the entire array by passing the input array and from 0 till the n minus 1 position, right? So this will just reverse the entire array and this will be my final output. I will have the rotated array in a counterclockwise direction by D steps, right? So that's the code. Now maybe we can test it. We have already declared this array over here. This is something that we can use as a test case. I will just print the original array first, and then I will call this rotate array function on top of this array, and then I will print this array again, right? Just to see the difference after and before calling this particular function. Now if I run this, let's see what happens. Okay, so there is a problem. Okay, yeah, I also have to send another parameter over here, which is D, and my D is actually equal to 2. In this particular test case, my D will be equal to 2. Now if I run this, yeah. So this is my original array 1, 2, 3, 4, 5, and after rotation, now it has become 3, 4, 5, 1, 2. And that's exactly what we wanted. And this is how we solve this particular question. So I hope you like this particular question and this particular solution. We used an observation to solve this particular question, and also like talking about the time and space complexity. Since we are just traversing the array once, right? While reversing also, we are just linearly traversing the array, and then we are just doing that reversal 3 times, right? So that will still keep the entire order of time complexity to linear only. So it will be order of n, the time complexity. And talking about the space complexity, since we have not used any space at all, so it will be constant. It will be order of 1, right? So time complexity will be order of n, and the space complexity will be order of 1, right? So I hope you understood this particular solution entirely, and I will see you in the next video. Thank you.